I'm Dean Eccles. I'm faculty here in Sloan, and I'm also an associate director of Institute for Data Systems and Society. And we're doing something for the first time here with a really special guest, which is having a joint seminar between the Applied Micro Seminar and the IDSS Distinguished Speaker Seminar Series, which is great, especially because the seminars currently are scheduled in conflict with each other. So this is really our chance to come together. And we have an excellent speaker today that I think a lot of you already know him and his work. Jesse Shapiro is professor of economics and business administration at Harvard, and among other accolades is a MacArthur Fellow. And I think we're really interested to hear about what's newsworthy. I believe that we're going to follow kind of the applied micro norms and hold questions for the first 10 minutes or so. Really looking forward to this work. Let's welcome Jesse.
Thanks, Dean. Thanks, everybody, for being here and for giving me the chance to talk about this work. I'll also say I've been visiting MIT this whole year, so thank you to the Institute for the hospitality and to all of you for being so warm. I really appreciate it. It's been great, and looking forward to a few more months. So this is work with Luis Armona and Matt Jensko and Emir Kamenitsa, and we were motivated in this project by a very large literature, goes back a long way. It's mostly not in economics, that hypothesizes and in some cases looks for evidence for different kinds of bias in news reporting. And probably we've all thought and heard about political bias, but this literature looks at many, many other forms of bias as well. So for example, negativity bias, the idea that the news focuses on bad things rather than good things. Or sensationalism, think about plane crashes versus car crashes. Or compassion fatigue. People get tired of hearing the same sad story about some foreign land, and so the news moves on and talks about something else, even though bad things keep happening. Or maybe bias towards talking about events that affect one group of people at the expense of talking about similar events that affect another group of people. So lots of different possibilities. And running through this entire literature over its many, many decades across many different areas of social science and communication studies is a conceptual challenge, which is what would it mean for news to be unbiased? Now, if you think about that for a minute, you realize there are some very simple benchmarks that are easy to describe, but aren't very satisfying. So one might be news outlets should just tell us everything that happens. Okay, that clearly isn't very satisfying. Like, this is what happens if you go to the National Weather Service, or at least if you did, when there was one, and you clicked on all the checkboxes, tried to get all the data they would give you about the weather. It's like TMI. The whole point of having news is to digest information and give us less than all of what happened, just what we need to know. Another benchmark you might think of is maybe news outlets should report events in proportion to how often they occur. And if you think about it for a minute, you realize that can't be quite right either. Because in that case, there would be lots of news stories about sunny days in Los Angeles or San Diego, but we don't really need the news to tell us about that because that's normal. So the goal of this project is to try to offer something to this literature that is a little more sophisticated and tries to take seriously some of the limitations of these hypotheticals. And so in particular, what I'm going to try to do is develop kind of a normative model of the news. It's going to be a model of benevolent, selective reporting in which there's an outlet that wants to report things that are useful to a consumer. And I'm going to show you that that model implies a formal notion of what it means for something to be newsworthy. I'm then going to take that formal notion prescribed by the theory and use it to interpret data on nightly television news broadcasts in the United States. And in those data, I'm going to be able to calculate the theory-implied measure of newsworthiness and show that it's predictive of many interesting patterns of reporting in the data. And then at the end, if I hopefully have convinced you that this measure of newsworthiness is useful, I'm going to come back to where I started and look at some settings where at first glance it might appear that there's something that the literature might call a bias. And I'm going to show that actually in some cases controlling for this notion of newsworthiness reduces the appearance of bias. So I don't know, is your norm 10 minutes or is your norm to the end of the intro? That's the end of the intro. So I guess 10 minutes, OK. So it'll be much of the paper, but that's fine. So in this next section of the talk, I'm going to take you through our model of benevolent, selective reporting. Now, the purpose of this model, it's something that I should be very clear about. The purpose of this model, you can think of this as kind of a model with normative intent. So we're not going to try to capture all of the realistic elements that actually influence news coverage and practice. Consumer psychology, the role of market structure, which are things that we have, various of us on this paper have thought about and worked on in other contexts. We're going to put aside many of those things. And instead, we're going to try to encode what I think are the two compelling normative features or essential normative features of a theory of selective reporting. One is that attention is costly, so we don't want to report everything. That's motivated by the first hypothetical straw person that I showed you. And the second is that information is useful when it tells people something they didn't already know. And so that means we're going to want to tell people things that inform them. And those are going to be the two key ingredients I'm going to try to roll in.
Hey, Jess, I'm going to break the rule.
Yeah.
Why wouldn't the third normative thing?
Aren't you the chair of the department?
Wouldn't there be an unbiasedness criteria that you want in normative setting? I don't see anything about that.
Yeah, I will show you how we try to operationalize that, and I'm happy to talk about it then and get your thoughts on whether there's a different way to do it. But here we're going to look at things. You'll see, but here we're going to imagine that the outlet wants to do what the consumer would want them to do. So we're going to take the consumer's goals as the starting point. Yeah.
Of seminars. Does an instrumental value of information include a pure utility value of information?
No. And you'll see where that's going to matter in the model. So this is going to be like a very kind of, I think of it as kind of a very pure model of news as information. I'm going to tell you something, and you're going to do something different as a result of what I told you. And you know what you do different might be that you just believe something different or whatever, but
Just like, oh, that was like interesting to know.
yeah, that's not going to be in here. So for sure that must matter. And some things are more entertaining than other things and so on. And all of that is gone here. And we're going to show that even though all of that stuff that definitely does matter in practice is gone, we're going to be able to get, I think, many things in the data right. So we're going to have a model where there's a state of the world, omega, that is realized according to some prior distribution f. There's going to be an outlet that's going to learn the realization of the state and then can make a decision to either report the state or not report it. There's going to be a consumer who learns the report, and if the realization is reported, the consumer learns the realization, so you can think of it as like a setting with verifiable reporting. Or they learn there's no report, and then they're going to choose some action A in some action set. And then based on their action and the state, they're going to realize a loss, L. Okay? Moreover, the other piece of the consumer puzzle here is going to be that if the outlet does report the realization, the consumer is going to pay a random attention cost gamma. Okay, so you can think of that as kind of a stand-in for the fact that if I tell you about one thing, there's something else I'm not telling you about. Or if I put something above the fold, something else had to go below the fold. And we're just going to treat that as kind of an exogenous random thing. But really, I think it's a kind of a stand-in for an opportunity cost. And the outlet is going to behave in the consumer's best interest. Okay, so now I'm going to solve the model. So that's the whole model. Now I'm going to solve it working backwards. So we're starting at the end. We can think about what's the consumer going to do. So one possibility is the consumer doesn't get the report. Then all they have to go on is their prior. And I'm going to let A star of F denote the optimal. You can think of it as like the default action they'll take based on their prior. The other possibility is that the outlet does report the realization. And then the consumer can take the ex post optimal action, A star of omega, which is their optimal action given the knowledge of the realization. Okay, so ex post, given that the outlet knows the realization, the outlet perceives the benefit of reporting to be just the increase in loss associated with the agent, the consumer, taking the action, the best action under their prior rather than the ex post optimal action. And of course, because this is the ex post optimal action, this is always weakly positive. So that's the benefit of reporting. Now there's a cost of reporting, which is gamma, right? So that's again the opportunity cost of reporting on this instead of reporting on something else. And as a result, because the outlet is benevolent, the outlet's going to report when the benefit of reporting exceeds the cost of reporting. Okay, and that's this condition here. So you can see in this condition the two forces that I mentioned before. One is attention is costly, so it's not necessarily going to be a good idea to report everything. The other, and this relates to Amy's question, is that information is instrumental. So it matters to report something to you to the extent it's going to change what you do, or you can think of it as changing what you think.
Is this an equilibrium model where consumers know the reporting strategy and back out, or they just
No.
they always stick with their
Yeah, it's a non-equilibrium model. We have the equilibrium version of this model up to sort of like exactly how you solve for the fixed point. This part of the structure is kind of the same. You just replace this with like an equilibrium perception. In the empirical applications, we actually went and calculated what that should be. And for practical purposes, it makes very little difference. One way to think about it is just in a lot of the settings, although not all of them, in a lot of the settings we look at, the ex ante probability of reporting is pretty low. So knowing that nothing was reported doesn't actually tell you very much. But there could be other situations like, if I thought about other kinds of situations like this, I'm a CEO talking to analysts. If I choose to avoid a particular topic, that may contain a lot of information for you. So I think in some situations that's likely very important, but it doesn't turn out to matter very much in our applications. OK, so this is our optimality condition for the outlet. Now, and here it is again. If we impose some distribution on gamma, so we say, OK, now gamma is random. There's a random opportunity cost of reporting. Then we integrate with respect to that distribution. We arrive at a probability that the outlet makes the report given some prior f and some realization omega. And we're going to summarize that probability with what we call a reporting function, r star. So a reporting function takes a distribution and a realization, returns the probability that the outlet will report that realization if the prior was that distribution. Okay? And of course, implicitly, this r star, this is inheriting the shape of this loss function. So that's sort of, in some sense, the answer to John's question. Whatever the consumer's interests or motivations are, they're getting rolled up through the loss function into this r star. It's also, of course, going to be determined by the shape of the distribution of this thing gamma. So all of those things are kind of parameterizing this function r star. Okay, so that, in a sense, is going to summarize the solution to the model. There's some probability of reporting that has to be represented as a result of this optimality condition. And our main theoretical finding is very simple. It is that an optimal reporting function, r star, has to be increasing in some proper scoring rule. Okay, now, if you know what a proper scoring rule is, then this may or may not be interesting to you. But I know that when I mentioned the possibility of doing a paper, talking about a paper on scoring rules, Dean got very excited. So I know there's somebody here who cares about scoring rules as much as I do. If you don't know what a scoring rule is, or you don't remember from when you last saw this, then this statement is just kind of like one thing is monotone and another thing. It could mean anything, right? Some function's a function of another function. Thank you very much. So let me tell you what a scoring rule is, and then you'll see, I think, where the economic content of the statement is. And then I'll talk about why we think this is a useful observation for doing empirical work. So scoring rules were developed originally as a way to penalize a forecaster. So you're a forecaster. I want you to tell me what you really think about something, and I want you to give me your whole distribution over it. So maybe it's like how many inches of rain will fall in Cambridge, Massachusetts tomorrow. Okay? And I don't want just like a point estimate. I want your whole distribution. So I ask you to tell me your beliefs f hat, like say a CDF, probability that there's less than 0.1 inches, less than 0.2 inches, and so on. Tomorrow, we will not, of course, know what the right distribution was. We will only see how much rain falls. Okay? But we can still penalize you, because that's what we like to do. So we're going to make you pay a penalty that's given by this score. That's a function of what you reported and what happened. And if this penalty function is a proper scoring rule, then you have an incentive to report your true belief. Okay? So intuitively, how is that going to work? Well, if you say you're really, really, really sure it's going to be less than 0.1 inches of rain tomorrow, and there's a flood because there's 2 inches of rain, then we're going to penalize you a lot. Okay? So in a sense, so this is how these things were developed. They were developed to incentivize forecasters. And so in a sense, the score is high when the realization of the state looks weird relative to the reported belief. Okay? So we're just taking that same idea and interpreting it in a different way. It's the same function class. We're saying the score measures how much news there is in the realization. How different what happened tomorrow is from what you would have thought would happen based on your prior. Okay, so in a sense, the score S that takes as input the prior and the realization is telling us how much news there is in the realization relative to what someone might have expected to happen. Okay, so in Los Angeles, a rainy day might have a higher score than a dry day. In Seattle, it might be the opposite. It might be that the rainy days are the norm, and so actually it's only interesting if we actually get a sunny, dry day. Yeah, is that?
So, Jesse, for this to be true, is it right that gamma has to be independent of iota?
Yes, that's true. Yes, that's true. That's true, yeah. So this R star, we're taking a fixed CDF. Another way of saying is we're taking a fixed CDF of gamma and integrating this condition with respect to that.
And the statement is holding L of A star omega fixed.
The statement is that, the more formal statement that's underlying this is that, yes, exactly, for fixed L, exactly. Yeah, exactly. And then in fact, there's an if and only if statement, and there's a little more structure you can put on those proper scoring rule, but I think the important bit is this bit here. Yes, it's for fixed L.
And the definition of increasing in means that R star is a monotonic function of S.
Yes. Yeah, and I'm not going to show it to you, but the proof is just to show that the regret function is a score, and then that's it, right? So that's all it is. So.
How should we be thinking about gamma and the idea that it's this distribution? Is that helpful just for, kind of lots of random utility models, we have this random component, or do you actually want to think about that as part of maybe whether the news outlet is hitting their budget for what's on the fold, or?
Yeah, so our application is going to be to television news, and one of the things that's nice about that is there's a very sharp notion of what is and is not covered in television news. So you don't have like a 2-second segment on the stock market that just says like stocks went down a lot, and then you kind of move. You talk about it. You have a person with a microphone like standing in the pit and talking about what's happening, and so that gives you like a very clear notion of what is and is not covered. Something that I think one could do with this, which we have not done, but I think would be interesting, is we're going to look at when ultimately we come to applications, we're going to look at different domains in isolation from each other. But something one could do is try to parameterize a model of kind of all of the different topics one could talk about in a given day, score all of them, and then trigger it as like a multinomial choice problem. We have to pick, we have time for 5 segments or whatever. We're going to pick the 5 highest scoring segments, something like that. And I think that would be an interesting kind of direction to go, but we have not tried to do that. Okay, so mathematically, I love scoring rules, but beyond the aesthetics of it, all I've just said is like one function is a function of another function. So why is this a useful observation? Basically, I interpret the result as telling us we can measure how newsworthy a realization is by its score. Okay, and conveniently for us, really smart people have been studying scoring rules for a really long time. So like we're talking about people like Savage and other people that you've heard of. Okay, and we know a lot about them. And there are some good ones that are really easy to calculate. And so that's going to mean that this idea is actually something we can operationalize in data. And to do that, we're going to want to put some discipline on it, because although this puts some structure on things, there are a lot of proper scoring rules in the world. We're going to discipline and tie our hands by looking at a particular one, which is my favorite one. And my favorite one is called the continuous ranked probability score. And it's this here. So this is like a divergence between the prior and a Dirac mass at the realization. Another way to say it is it's like a measure of how different the prior is from the posterior that you would have after you learn the realization. And to get some intuition for how this works and sort of see why maybe I like it, and then you're taking the, so to build some intuition for this, let's go back to like our weather forecaster and think about, we ask them a simpler question. Don't tell me your whole distribution over the weather tomorrow. Just tell me the probability that you assess that there'll be less than 0.2 inches of rain. And then I'm going to compare your assessment to an indicator for whether there actually is less than 0.2 inches of rain. Take the difference and square it. It's well known that if you're an expected penalty minimizer, you have an incentive to tell me your true probability. CRPS just takes that idea and scales it up over all possible thresholds I could have asked you about to elicit, truthfully, a distributional forecast. And then we're going to integrate that thing with respect to Lebesgue measure. So I like this one for a few reasons. One, it generalizes the simple quadratic scoring rule, which is used a lot, and we see a lot in economics. Two, because it only depends on the distribution through its CDF, you can use it in cases where you have point masses and continuous parts of the distribution and all kinds of stuff like that. You can use it out of the box, so there's no shape parameters here that you need to tune. So that's going to be good because I'm going to want to try to convince you that I can explain lots of facts in a disciplined, parsimonious way. And this comes back a bit to John's question. And this I don't quite know how to formalize, but it's kind of obvious from looking at the equation that CRPS doesn't know anything about the context. So it doesn't know anything or doesn't depend on anything that we might think would cue biases from humans. For example, it doesn't know whether high omega is good or bad, right? It doesn't know if like omega is a thing like the stock market price, which you like to be high, or a thing like the amount of rain, which maybe you like to be low. It doesn't know who we're talking about or what we're talking about or whatever. So in that sense, it has a kind of symmetry. Yeah, John.
This seems so obviously, this to me, you've convinced me, this is like the right probability score. But you said it's one of many you could have chosen. What's its weakness? Like, what would be what's an alternative that you might like under different
I mean, if we were, okay, so I'm so glad you asked that question. There's a large space of these things, but if you thought about like kind of off-the-shelf canonical ones, like another one would be the log score. And actually, that one you can't really use, I think, with discrete continuous distributions unless there's some trick I don't know about. Later in we actually just started with this one because it seemed appealing and generic. Later in the project, we did actually check what happens if you use the log score, and it doesn't explain the data as well. And there's some reasons for that, having to do with well-known properties of that score. But anyway, I really like this one.
I guess coming back to my question on previous here.
Yes.
This is again holding the loss function for the W fixed, and like if I think about the weather forecaster, he can either tell me that there's to be a tornado tomorrow, or in 15 minutes, or that there's to be a conjunction of Mercury and Venus in 15 minutes.
Yes.
They may have equal likelihoods in this measure, but you don't.
Yeah.
So the thing is, you do want to rank from this measure if they're as important to you in terms of impact on your decision.
Yes. Yeah. I agree with you. There's another dimension here, which I don't know how to capture in quite as parsimonious a way, which is like, some stuff that we can put in a similar scale is irrelevant, and some stuff is very important, and I'm not sure how to capture that in quite as disciplined of a way. So for much of what I'm going to do in the empirical work, I'm going to look basically like over time within a domain when these issues aren't as first order. I am going to do some comparison across domains, but I'll show you why I think that still could be interesting even with this metric. But I think clearly if you wanted a fully complete theory of what gets reported on the news, there's like an ingredient that's missing. And I think it's clearly an ingredient that we would see, it's a prediction that we would see violated because we would see that there's a lot of celebrity news. It's not actually that relevant for people's day-to-day lives, but they really want to hear about it. And this, I don't quite know how to capture that. So I agree. That's an element that just is missing here, I think.
Do you mean you don't know how to capture it theoretically or empirically?
Capture it in a way that I know how to operationalize in data, yeah.
Conceptually, you introduced earlier this notion of actions taken as a result of F or omega. So couldn't you just have the scoring rule be a function of those actions rather than the realization of and the difference in actions between whether you were under F or under omega?
So, I mean, one way to think about it is this particular scoring rule is implicitly imposing structure on the loss function. It's imposing a particular regret function. Something we could do to incorporate what Glenn's saying is we could multiply it by a number. We could say this is like a 10x important context and another one is a 4x important context. And that would be like scaling the loss and saying some things matter more than others. Where I am a little bit unsure where to go is how to operationalize that in a disciplined way. That would sort of tell me how much more important is the stock market than Britney Spears or something like that. Yeah, exactly.
Conceptually, it would be easy to incorporate.
Yes.
Okay.
Yeah.
That's what I want.
Yeah. And the model doesn't take any stand. I mean, implicitly in the model, L could be anything. So it could be very important or it could be not very important.
Sorry, L isn't in here. I think that
L went away because L was basically by using this particular scoring rule. So back here, L matters because it determines the shape of the score that justifies the particular reporting function. But now I did like a little bit of a sleight of hand, which is I replaced any scoring rule, right, some proper scoring rule, with my favorite one, S naught, because I don't really know how to like elicit the relevant scoring rule for a given domain, and so I'm going to try to do something parsimonious.
Actually, exactly on that point, do you know something about what else generate this?
I mean, other than, I guess, like, we can always, like, there's a trivial answer to that question, which is we can always cast any decision problem as just, you tell me a distribution. Like, we just replace the action space with a distribution space, and we just replace the action as the optimal action that would have been optimal under any other formulation of the decision problem with that one. And in fact, that's how the proof works. So in that sense, it is, like, this is a loss function in that sense. So
Is there a simple, like, something?
I don't know of another characterization. Yeah, it's kind of a question about characterization of this scoring rule, and I don't know of a result that gives another way to think about it. I mean, the quadratic interpretation obviously works, but I don't know of it like another representation of it.
Just other small thought, but just for celebrity news, there's an interesting question of would anyone ever care about learning celebrity news if they never were going to talk to their friends about it? Right. So maybe it is action, though.
Yes. Yeah, fair, exactly. And I think this part of what I think makes it, I'm not sure, like, as I'll show you, the ingredients to operationalize this are in some sense very easy to get. The ingredients to operationalize that, I'm a little less sure how to get them. But someone creative may be able to do it. OK, so what I'm going to do now is I'm going to follow a very simple recipe, because I want to see if this can actually has some bite in interpreting data. I'm going to get data on reporting, R. I'm going to get data on realizations, omega. I'm going to get data on priors, F. And then I'm just going to look in the data and see whether more newsworthy realizations, as measured by this particular score, are more often reported. Okay, so let me tell you how I do that. So we're going to look at 4 different domains. We're going to look at the stock market, where the state variable we look at is the return. We're going to look at the labor market, where the state variable we look at is the BLS reported unemployment rate. We're going to look at the weather, where the state variable is the average precipitation in the US. And we're going to look at war, where the state variable is the number of US military casualties on a given day in either Iraq or Afghanistan. And for all of these, we're going to measure reporting on television nightly news. So our data are going to come from something called the Vanderbilt Television News Archive. This basically has written summaries of the nightly news broadcasts. We used like old school text analysis to code these. Like we just look for if they say stock market, it's typically a segment about the stock market, and so on. And then we validated what we did with human classification. Everything I'm going to do for the reasons I said and to match the structure of the model is going to just be kind of treating the outcome as just, is it reported or not? But the results are very similar if instead you look at how much time is devoted. And the reason is for the reason I said, which is segment length is typically just kind of fixed. Like most segments are around 2 minutes. There's not, most of the variation is on kind of the extensive margin of do you cover this topic. Yes, Sarah?
So there were some, in the time period that you're looking at, there were some pretty significant regulatory changes that had to do, that were relevant to content on US news reports during that time. Are you just not worrying about that?
We're not worrying about those. Are you talking about the fairness doctrine, or are you talking about some?
Broadcasting for in the public interest, although that stuff kind of went away in the 1980s.
Yeah, I mean, we're going to be, I mean, as you see, we're mostly not focusing on political bias here. And I don't know how much those changes actually influence the way the outlets thought about these kinds of topics, but I haven't looked at that. So I guess the simplest answer is no, we're just ignoring that. OK, I said this. Yeah. Probably, so getting data on realizations, that's easy, right? So that part I don't need to discuss. Maybe the most intricate bit here is getting data on priors. So we want to kind of be somewhat disciplined. because if we can pick any prior, we can probably explain lots of things. So what we're going to try to do is come up with a kind of reasonable, not super fancy time series forecast of the state that we're going to calibrate to real data in each case. And I'm going to discuss in a little bit of detail what we did for the stock market, and then I'm going to just kind of flash up a slide that discusses the rest. Once you see what we did for the stock market, I think the rest is intuitive. So for the stock market, the realization is going to be the log change in the closing price of the S&P 500. The prior is going to say that the realization has a constant. It has some drift that depends on the risk-free rate. This is like a T-bill rate. It can depend on the volatility, and then there's like a Gaussian error. Okay? And we know that's going to like have too thin tails and things like that. So it's kind of a crude, simple first approximation. The volatility, in turn, is allowed to depend on lags of the realized volatility. That's this term here. It's allowed to depend on lags of itself. And then it's also allowed to depend on the VIX. So the VIX is an options-based measure of the market's perception of how volatile it is. So this is kind of a nice context because actually you can learn the volatility of the market from the market. So all in, this is a model with like a little bit of a time-varying risk-free rate and then time-varying volatility. That's, of course, going to move around a bunch. And we're going to fit these lag depth terms with cross-validation. And then once we've done that, we can fit the rest with maximum likelihood.
Maybe this is related to the question of that the consumer behavior here is not really equilibrium behavior.
Yeah.
But I guess in some settings you might think that the consumers are forming their priors based only on the cases where there's reporting.
Yes. Yeah, so formally the way we solve that problem in the theory is just imagine that at the end of every period, consumers learn the state no matter what, one way or the other eventually. Like they make their choice, and then somehow they magically learn the state. An interesting and sort of different problem would be one where they're maybe accumulating knowledge about something only based on what this outlet tells them. And then there's like a state variable, which is what is their belief that's being influenced by the outlet. And we haven't tried to solve that. I sort of suspect that what you'd end up with is like an SS problem, but in divergence type space, where when I know, again, because I'm benevolent, when I know that your beliefs get far enough from the ones you should have, I will make a report to you to kind of bring them back together. But we have not tried to, beyond talking about it, have not tried to actually work that out.
So Jesse, this one has this very nice feature that you have this VIX thing, so you have some like actual thing in the data that's like directly about the volatility.
Yes.
That doesn't seem to be true in your other examples, is it? Or
so,
you must rely more on that kind of the beta P term?
Well, they're all going to be a little bit different time series models. So it's not that we're fitting the same model to all of these.
They're not going to use the VIX for the weather.
They're not going to use the VIX for the weather, but also we're not going to assume the weather has the same structure as this. So like for the unemployment rate, a big thing is just allowing for seasonality. Like that ends up being a big thing there, and then we use just like a Garch for the volatility.
The reason I'm asking is that obviously the key thing is not just predicting the mean; it's about predicting the variance. So like for your thing, the variance is really important. So
it's the whole shape of the distribution, and I mean in a sense, and what you'll see, I think, in the figures is what's kind of nice about using this score, which just sort of takes a CDF and spits out a number, is it adapts in a very natural way to the fact that these different things are distributed differently. So they have different shapes, and you're going to see that in the calculations. I mean, we've also done.
The weather, it feels like you should be able to do something much more parametric. Like there must be some VIX equivalent. Like you do a lot of a sort of likely weather realizations, right? So.
Yeah, we have not tried to do anything fancy there. I mean, so we have like for the weather, we have like trigonometric functions that keep track of seasonality and things like that. We haven't tried to use like detailed distributional data. One thing that we have done, which doesn't fit as well, and I think it's kind of intuitive, is just use the observed like marginal distribution of the data, but then you miss a lot of the time variation in the parameters. Like you'd miss the fact that the volatility is varying. So that isn't my favorite approach, but it's an approach one can take. So yeah, I mean, from the time series alone, that's all you have, you need to be fairly parsimonious because you need to be able to figure out what the whole distribution function from just a small amount of data. If you have other sources that give you distributional forecasts or whatever, you may be able to get richer things. And like you said, that's exactly what we did with the stock market, like bring in the VIX to get more information.
weather, there should be an obvious.
Yeah, that's probably true. Yeah, that's probably true. So just to quickly say, so for the unemployment rate, we have a seasonally autoaggressive mean, a Garch variance. For precipitation, we're going to treat that as log normal with an ARMA mean. A Garch, I finally get to use all these abbreviations from time series class. A Garch variance. US military casualties, these are, of course, count data, so we're going to use a zero inflated negative binomial. The parameters of this thing are allowed to depend on the lags of the distribution, so that's kind of how there's some time variation in the prior. Okay, so what I want to do now is just take the model to the data and look at what the model says is newsworthy, and then look at what gets reported and see how well one matches the other. And I'll be able to do that in a few different dimensions. So again, let me go through stocks in some detail, and then I'll go through the other cases a little more quickly. So this is the log of CRPS plotted against the stock market return. Okay, so it's data in the sense that it's like from the observed world, but it's theory in the sense that this thing logs CRPS. This has nothing to do with reporting. The only ingredients to this thing are the prior and the realization. Okay, those are the ingredients that go into the recipe that makes this picture. And what is it saying? It's saying that when the stock market doesn't change very much, it's less newsworthy. When the stock market goes up or down a lot, that's more newsworthy. Okay, so that seems like sensible implication. And because this is not coming from data on reporting, we can compare it to the data on reporting in a very disciplined way, because we haven't mechanically used any data on reporting in constructing this picture. And if you make the picture of the real data, it looks like this. So this is a bin scatter. And because Isaiah is here, I'll say that this is using the Cataneo approved and Isaiah edited settings. Again, you get this kind of bowl shape where the days with the smallest magnitude of return are the least newsworthy days. So if you put these side by side, the model's doing reasonably well. It's sort of getting the qualitative patterns right. It also seems like it's kind of getting the shape, if not right, at least kind of reasonable. Now you might say, like any sensible theory of the stock market reporting is going to tell you that if the stock market goes up a lot or goes down a lot, you're going to report it. And if nothing happens to the stock market, you're less likely to report it. Okay, so fair enough. I think it's cool that it gets the shape right, but I agree that would be my intuition too. The model is a little bit subtler than that though. So for example, one thing, and this goes back to Ben's comment, one thing we could do is like split the data into the high volatility days and the low volatility days. Like you can think of it as like high VIX days, low VIX days. Okay? On high VIX days, nothing happening is actually interesting. Like if we're a few weeks after Lehman Brothers, if nothing happens in the market today, we want to know that because we went into today thinking, whoa, something might have happened. Okay? And so the model implies that. So if you plot log CRPS, now I'm splitting the data according to the dots, which are the high volatility days, and the triangles, which are the low volatility days. You see that the model sort of says that the bowl flattens, a little bit like working pottery. So the days with no return become more interesting. And then the days with more extreme returns actually get a little less interesting because you sort of thought that you were going to have an extreme return if we're in a high volatility period. And so this is, again, just from the theory. This is just what CRPS is saying, and this is the data. And if you'll give me a little bit of grace, I think there's some of that happening in the data as well, particularly in the low volatility periods. Yeah?
On the top graph,
Yeah.
the y-axis is some measure, the scoring measure of like...
It's the log of that score.
Right, so then why isn't what you want to show us is the probability of reporting against that log score?
We have that plot in the picture, but in the paper, and John actually made a very similar comment when I first told him about this project. But I sort of like these because they expose why it's varying over time. So there is a clear increasing relationship between those two. But I'm not putting that here because here we sort of see the economics of why it's happening.
Sure, fine. I'm not saying not to do this. I'm going to take all your points, but I guess when you're using this variance as a proxy for like, wow, that was like 0 is interesting today, but isn't that exactly what your y variable in the top one is trying to?
Yeah. So right, this is sort of like we're projecting a very rich thing onto a few dimensions to sort of understand it, And another thing we could do is just regress or just relate this to this, which we have those pictures. I won't show them today, but they're in the paper. Yes?
So if I take your model literally, it seems like this CRPS thing should basically be a sufficient statistic for
Yes.
the returns and the prior on the probability of reporting.
Yes.
So what I would have thought, like the strong implication should be, is once I control for the CRPS thing, the returns
other things don't matter.
and the priors are just independent of the reporting probability. Are you going to show us anything?
I will not, but I think you're right. So I think basically under this kind of the structure that we have where gamma is independent of everything else, we should get everything we need from F and omega. And so, yeah, I think that's like an over-identifying test of the model. I won't show you that, but I agree.
Step forward, in some sense, these things you're playing with, like the high and low VIX or whatever, you could think of as instruments for the CRPS.
Right, I mean, yes, it's true, although CRPS is constructed as a function of like a distribution that only really has, like on any given day, a mean and a variance. So there's not a whole lot else going on in it. But yeah, it's a very strong first stage, exactly. Yeah. And there's other testable implications too. So for example, like there's also limit implications. Like if the VIX collapsed to 0, then on a day when the realization coincides with the prior, you should have 0, like literally 0 reporting. So I didn't show that. But there's like additional structure that could be tested. OK, so let me show you similar kinds of facts for some of these other domains. So here's unemployment. So again, it's like not that surprising that high unemployment rate is a little more interesting than low unemployment rate. And the Night News is going to talk about the jobs report more when unemployment rate's high than the unemployment rate's low. That's what you're seeing here. Again, a little more interesting is the fact that the prior plays a role. So similar to the stock market, it matters where the unemployment rate used to be. So if the unemployment rate's the same as it was last time, that's not as interesting because that's close to what we expect. If it's more different, either above or below, then that's more newsworthy. And that again matches pretty closely the shape we see in the data. There's like this V shape. And notice that like, you know, the shapes here, like here, are different from the shapes here. So this is all the same thing. CRPS, the S naught is the same functional, but we're putting different kinds of ingredients into it. And because the shapes of the distributions of the variables are changing, the shape of the score effectively is changing. The way it looks on in these particular projections is changing. And so that I think is kind of indicative that it's you know, despite being parsimonious, it's able to adapt to many different kinds of situations. Okay, this is another illustration of that, which is precipitation, where according to the model, the least interesting days are the days with moderate amounts of moisture. Like if it's very dry, that's kind of interesting. If it's extremely wet, there's a lot of precipitation. That's very interesting. These days are the least interesting, and that again seems to match kind of roughly the shape that we see in the data. And again, this is entirely just putting in the like time series distribution density forecast into CRPS. Yes?
I like John's suggestion of like testing the model by
Yeah.
but even before you get to that, is there like, I mean, I like these graphs too, but is there anything other than like, oh, they kind of look similar, like a more formal
Yes.
way to...
Yes. I mean, all goodness, I think there's a sense in which all goodness of fit statistics are a version of they kind of look similar, but I've thought about that a lot in the context of this project. But we have calculated, so there's there's work that proposes this statistic completeness. So it's like how well can you do using this model relative to a very flexible model. So we've computed the quality of these predictions relative to a model that's allowed. So this is actually closely related to John's question from before. I didn't think about the connection until you asked about it. We've scored the completeness or the goodness of fit of CRP, of like a model that only says the probability of reporting is monotone in log CRPS versus a model that's allowed to have any smooth function of the prior and the realization. And in general, this model tends to do pretty well. And then there's also kind of analogous measures of parsimony. There are a lot of choices one has to make in developing these things, so they're not, again, I think there's still some judgment involved in deciding like what's good. But for what it's worth, we have calculated formal measures of goodness of fit and formal measures of parsimony. And they suggest this is a pretty good fit and very parsimonious.
Can you tell us anything about what's being reported on the days when it didn't rain? Like, is it, because like, it doesn't seem like an interesting news story to say it didn't rain in any state in the United States that you like,
right.
I have a hard time imagining that. So is it that like on days when it doesn't rain, there's something else being reported?
I think part of what's going on is this is not right. So we're looking at weather reporting, and this is precipitation, which is one dimension of weather. It's a little bit related to your comment before. So what I suspect is going on is that also on these like very dry periods, it's also hotter, and like there's maybe a heat wave or some other stuff going on, and that's driving a little more discussion of the news. Oh, sorry, of the weather. I should have said. Yes, John.
The thing you show here would be your Seattle versus LA.
Yeah, but these are national news broadcasts, so we haven't. That would be super cool, but we have not tried to do this with local news, but one could. And then this is military casualties. I won't dwell on this because I don't think these are that interesting. I'll come back to why this is an interesting context for us in a little bit. Okay. So what I want to take away from that exercise is that I think this is a very parsimonious way to measure how newsworthy realization is. And it seems to do a pretty good job capturing lots of facts in the data, some of which are very intuitive and then some of which are a little subtler. So now what I want to do is circle back to my original motivation, which is look for bias in the news and see if this can be a useful tool for disciplining tests of bias. And I'm going to do that in a super simple way. I'm going to pretend I didn't know about this measure and do something like what the literature might have done to test for bias, or in some cases literally what the literature has done. Then I'm going to control for this and see how much bias goes away. Very simple exercise. And we tried to come up with like a range of applications. We looked for things that would be the types of biases that the literature has talked about that are testable with our data. And we added one more criterion, which is when we do the initial test, before we control for anything, there's some evidence of bias. And actually, that turned out to be very binding. And that eliminated lots of things that the literature talks about. We just couldn't find any initial evidence. Even naive tests didn't show much evidence of those things. But so two things survive.
Is there a reason to do that? I mean, in some cases, it might be that this is masking.
Yes. Yeah, I agree. Yeah, I think conceptually, I think that's a fair point. Like it might be that there are some things that you don't see. The reason we did it this way is because the literature has never been looking at this using CRPS. So I guess the idea was to say, let's start from things that people have hypothesized or have shown evidence for. Let's use the kinds of methods they might have used. Let's see what survives in our data, and then from there we'll chip away. But it could definitely be that there are situations where there appears to be no bias because you're doing something that's kind of symmetric. But when we account for newsworthiness, it actually looks like you're treating two situations very differently. So I think it's totally fair. So the first application is to negativity bias in economic reporting. So it's a fact in the data, and this is something people had previously noted in the literature, that news outlets are more likely to report on the unemployment rate when it's gone up than when it has not. Is that because of negativity bias, or is that because of newsworthiness? So here is the coefficient from regressing, an indicator for did you report on this, on an indicator for whether the unemployment rate is strictly above the previous unemployment rate. And you see that there's what you might consider evidence of bias, like you're more likely to report on the unemployment rate when the unemployment rate is higher than the previous one. When we control for newsworthiness, a large chunk of that coefficient goes away. There are two reasons for this, one very mechanical and one a little more interesting. The more mechanical one is that in order to be strictly above where it was last time, the unemployment rate has to have changed. And as I showed you, changes are newsworthy. So that's like very simple. The other is that unemployment rate tends to spend a little more time in the right tail of the change distribution than the left tail. So it goes up a bit faster than it goes down. And as a result, it tends increases in unemployment tend to be a little more newsworthy than decreases. And the combination of both of those things is what gets you from here to here. Now, you could, through intuition, figure out, like, these are some things I want to control for. Like, I want to control for is it different, and I want to control for how, the overall magnitude. So I don't think CRPS is the only route to getting to this kind of discipline. What I think is appealing about it is that it's one thing you can calculate across many domains without having to do all that thinking. That allows you to operationalize multiple different ideas like that through one statistic. Let me show you another application that I think exhibits that by showing you that we can take the same idea to something somewhat richer. So in the context of the wars in Iraq and Afghanistan, US television news were more likely to talk about Iraq than Afghanistan. And that's not our finding. That's a finding that we reproduced that's been documented in the journalism literature. And there are various reasons one could come up with for why that may be. Okay. So here is what we get when we take the difference in difference in an indicator for reporting on Iraq and an indicator for reporting on Afghanistan and regress that on a constant. So this is like a very simple regression with just a constant. Okay? And then we just take that and we add to that regression the difference in newsworthiness. And when we do that, all of what looks like bias towards reporting on Iraq goes away. Why is that happening? Because if you look at the data, US casualties in Afghanistan tend to be either 0 or 1. So there'll be very many days with no casualties and some days occasionally with 1. Whereas in Iraq, you'll have some days with many because a group of soldiers will be ambushed, something like that. And as a result, the state variable, the realizations are more newsworthy on average in Iraq than in Afghanistan. So to visualize that, this is the difference in the probability of reporting, and this is the difference in the log of CRPS. And if newsworthiness explained everything, you would kind of want to fit a line through the origin or curve through the origin here. And you can see that that seems pretty close to like maybe where your eye is drawn to. And we've helped it by putting the origin there. And why, given this plot, does the uncontrolled measure show evidence of bias? It's hinted by the rug plot on the x-axis here, which is we're spending a lot of our time in this part of the distribution of log CRPS. So on many days, the newsworthiness of the casualties in Iraq is higher than the newsworthiness of the casualties in Afghanistan. And it's the combination of those facts that gets you to what I showed you on the previous plot. And what I think is appealing here is that, again, like maybe in the unemployment case, one could have use domain knowledge and kind of reason their way to like a reasonable set of controls. And maybe that's true here. But these are two very, very different domains that might require very different kinds of domain knowledge. CRPS doesn't have any domain knowledge, but is doing a good job, I think, helping us capture things that are there and discipline tests of bias.
Sorry, Jesse, can you just explain this in a little more detail?
Sure.
I thought your explanation was there was more variance in Afghanistan than Iraq.
Yes.
And I would have thought that
No,
it's the other way. There's more variance in the.
It's more variance. There's more like.
It was either like super extreme options. I would have thought that. Whereas I thought you said that Iraq had more of a.
No, the other one.
No, Afghanistan.
Iraq will be more days with like many casualties, and then a lot of days with zero. And so yeah, exactly. Yeah, exactly. And so like one way to think about it is like. There's both the ex ante and the ex post perspective. Ex post, there are more days where a lot happened in the sense of many casualties, but also ex ante, on average, you just know that it's more likely that there were more casualties in Iraq, and that also affects the score because it depends on the prior. So even like on the average day, the score is higher. Yeah. So.
In your textual analysis, are you only looking at news stories about casualty counts?
We're looking at news stories about the wars.
Okay.
Yeah. And it's true that like there's like a little bit, again, there's like a little bit of a choice here in sort of what is the state variable that we made some decisions about.
It'd be interesting to just see some kind of descriptive
Yes.
information about what the news stories were like.
I guess this is sort of related to choosing that state variable, and also the question of the idea that at the end of the day or the next day, all the consumers are observing the state of things. But you might think part of what could be newsworthy in Afghanistan is an accumulation
Yes.
of casualties.
Like, so it's
And-
dynamic. It's for several days consecutively.
Right, and
Yes.
if you haven't told me recently what has accumulated, then I could be very surprised
Yes.
by the news of the.
Strongly agree with that. Yeah. I think that would be really interesting to look at. We haven't, but I think I have a similar intuition.
Your model of the score thing had like lags in it.
The model of the prior will have lags, but I think what Dean has in mind is like, imagine, so well, I don't want to speak for you, Dean, so you tell me if this is wrong, but like imagine that the consumer doesn't know what happened in Afghanistan unless I tell them. So it might be that, you know, if there have been 5 consecutive days with casualties in Afghanistan, and that's kind of unusual, even though each individual one wasn't that surprising, the fact that there are 5 cumulative ones is very surprising, and they may want to update their like prior distribution. In our model, that's not going on because at the end of every day, we assume that the state is known to the consumer, and so their prior is a time series prior. And that's why we're able to justify, you know, at least in an internally consistent way, using priors that are fit to time series data that assume that, you know, whoever holds this prior must have been able to see all the lags. But in reality, it might be that the real consumers don't know the lags of the number of casualties. And so we'll get.
Sorry, the prediction for what's reported is not a function of what has been reported. Because
Exactly. That's exactly right. Exactly. This is not a dynamic model. And the dynamics are shut down by the fact that whether I report or not, eventually you're going to know what happened, and so your prior is going to be your prior tomorrow, and I can't change it. But Dean's envisioning, I think, a world where that's not true and where I can influence the like distribution you're carrying around in your head about the state variable.
Or if there was just a bias of the form that, like, once I've reported on something, I feel I should keep reporting on it.
Right. Or the opposite,
Okay.
maybe there's fatigue bias, yeah. So the normative benchmark here exhibits none of these things. Yes, John.
Example for your bias might be reporting on weather and climate change.
Mm-hmm.
It seems like nowadays bad weather is interpreted as evidence for climate change. And natural disasters seem to get more headlines maybe, and you would never know from reporting on hurricanes that the fatalities have generally been falling. Related to bad weather.
So you're saying maybe we could show that controlling for how newsworthy things are, there's more reporting of extreme weather events than there used to be because of attribution science or you know, relationship to climate change. Yeah, that's interesting. Yeah, we have not looked at that.
Well, I guess that highlights also the complexity of what the score gives you, because if casualties from hurricanes have been consistently falling, then that makes casualties from hurricanes more interesting. Like the same number of casualties from a new hurricane would be more interesting if the casualties have been falling and I'm updating my prior. No?
Well, it depends what you do. Yeah, if you divide it by last year's casualties or something, it's a bigger number. If you divide it by population, it's small. Objectively, it's small risk. It's declining risk. I don't know how the analysis would come down.
We have not done it. But yeah, I agree that's interesting. I hadn't thought about that application. And I think, yeah, I think it illustrates like our goal here was to come up with like a number you can calculate in data that sort of tells you how newsworthy something is, so that when you have questions like this, you have some kind of a benchmark, which is not report the same as you used to report, or report everything, or report randomly, but something that accounts for what we think are kind of important normative elements of the reporting decision. So yeah.
It does require a good time series model for the prior.
You need to have a way to get a prior, yes.
And have you explored, like, you know, the different ways you could have gotten that prior, right? How sensitive is it?
We've explored like a little bit of fiddling around, but not, you know, all over the space of possible ways to. But yeah, we've done it a few different ways and perturb the parameters and stuff. And I mean, you generally get a fair amount of bite from CRPS, sometimes less, sometimes more. But we certainly haven't explored it exhaustively. And of course, like an interesting issue here is what do consumers actually think, like, which is what in the model it should really be about. we have some of these settings, we know a little bit about that, like there's a survey of consumer expectations, you can look at the unemployment rate. We've done some of that, but we haven't gone all the way to like trying to elicit beliefs, and, but one could. Okay, so this project aimed to develop a parsimonious model of benevolent selective reporting. That model delivered a measure of newsworthiness that you can take to data. That measure of newsworthiness predicts many key patterns in US television news reporting, and we think it's promising as a control variable. When someone wants to assess a claim of bias, like Josh is talking about, one can put this in as a control and see if evidence of bias survives that control. Thank you.